Hi guys, and this is the first episode of what might become a regular thing, which is AJ's Scattergun, which was based on a comment I made to Ace about how I take a scattergun approach to games and just sort of play random games, be they ones I've got really cheap on Humble Bundle deals, ones that come through subscriptions to Xbox Game Pass or Origin Premium, the Origin subscription service, or through Twitch, through 3 games you get with Twitch Prime. So there's 3 different sources for sort of just random games, which I may or may not like. And Ace's or Game Grid rather has sorted me out a license for Wild True Learn, which is on Steam. So I have got no idea what this game is about, really. Other than from the title, it sort of implies a sort of pseudo programming element to it. So that's it. I fired it up for the first time right now, and let's hit it. I'm going to play this for about an hour and basically just see, is it any good? Flashing triangle, power outlet. Okay. Okay. So it implies it's a very drag drop. Okay. I'm a very overworked programmer who doesn't know what he's doing and he's relying on lots and lots of caffeine. That makes sense. So your cat is apparently better than you are. Cat overflow. Again? Right, so if it's ready, yeah, okay, so we're dealing with a simple switch here. So anything red goes to the first bit, anything not red goes to the other bit. That's, yeah. If else. Okay. Let's use my name in it. Behold the task tree. This is the map of your progression in the game. Vertical progression stands for story quests. Horizontal branches are optional. Icon colours stand for different types of machine learning texts used in respective tasks. Sounds pretty simple, or so we hope. Okay. So it sounds like it's a side quest or story quest. Good day, we're from a public school. Summer exams have passed here already. The results are attached to the letter. Could you process it and predict which of the students will be able to enter the MIT? Okay. So you've got outgoings and... Right, oh, that's the total money. You get paid for the jobs. Okay. Okay. So that's getting rid of data. So I think the idea here is that, yeah, you are actually producing something that is, to a certain extent, real world. So if it's red, we'll go straight there. If it's not red, we want to go into this one. Then if it's green, we also want to send it there. We need a trash can, and if it's not green, there we go there. So all blue, all the reds will go straight into the output stream. All the greens will go into here and then get into our output stream. All the blues will go into there and then get dumped. I think I can release that because I know it's going to work because I have vague brain cells. And I do programming in real life, so this is actually sort of a nice way of doing it. I wonder how this relates to the sort of visual programming languages they've got on the Pi that sort of come with the Raspberry Pi. At least they come with Raspbian. Might be interesting to find out. Ooh. Request from a colleague to actually watch me play this. So that worked. Again, I did it in time, I think. Okay. Ooh, making bank here. So I've got I think the point here is that I've got to take these if then else's and so on, and be able to use something that says this is a cat, I think. So it's just taking me back. Although, what's the point of the empty bit? Or is this just sort of a confirmation that I know what I'm doing? Quite sure what was going on there. I might have overdone something. So this is back to our original stuff. Hang on, what's going on here? Right, so oh, I might have been doing this upside down. No? Okay. Now, if I remember, Eliza wasn't really an expert system, was it? If I remember, Eliza was just sort of turned everything that was told to it into a sort of question. So if you said I'm sad, it would just say, why are you sad? It wasn't. I don't remember it being an expert system, but okay, I might be wrong. This icon indicates how often a custom block can start processing of the relevant data. Oh, so I think your information as it goes into these blocks gets sort of backed up. Okay. So hang on. This seems a bit inefficient because it's waiting until all the red data goes. Oh no, there we go, there's some red. Okay, we're still in time, I think. This is kind of neat. So you can sort of create blocks of intelligence and then reuse them. I think that's the point. That's the point. Cool. cool. Yeah, I was doing this the wrong order. Illuminate what? So how do I do that one? How do we do that one? Oh, right. Now, many years ago, when I was at university, I remember there was a system that because I did specialisation in graphics, I remember there was a program called WIT, W-I-T, which you could give it a picture and you could apply various things to it to sort of work out how many objects were in the picture, for instance. I mean, this is when I was, just hitting my 20s, so I don't really remember what it could do, but I suppose that might relate in a vague way to this. I'm liking the fact that it's got, a relationship between what you're doing in the game and what actually happens in the real world. Okay, so I want greens and reds, or either. I think this is the sort of number we've got to get to, and then we've got either fill that with greens and reds, or fill that one with greens and blues. If we only filled them with blues and only filled that one with reds, that would still achieve the task. And I think what this is saying is that you could do this in two ways. You could use two of these, or it's saying that there's a random element to this. So if we made that one red and that one blue, if it's not either of those, it's going to send them to either one or the other on a random basis. And because that's quicker at processing an output than this one, this should be quite fast. Yeah, I get you. And now we've done that one, now we can go and look at these side missions. Okay, so they've changed their data somewhat, and can you change the code? Now this is disturbingly similar to what I actually do in real life, because I work with databases, so this kind of decision work is sort of key to what I do. Now they only want red answers here, so we're going to chuck it in there. And if it's red, we want to go there. If it's not red, ooh. Now, all we want is a not red here. Now we could stick. Now this is cunning, because this one could say everything red go into here and everything not red go to the trash can. Now that takes a second. If this takes 0.3 of a second, what we can do is stick 3 of these together. So if it's green, oh no. No, I'm not sure now. No, there. Yeah, that's how you do it. So, if it's neither of those, it'll go into a random one. Now, if it goes to this one, we don't care. If it goes into this one, we need to filter it again. And this time, if it's blue, we want to send it to the trash can. And else we want to do that. Now that's 0.6 of a second in total, as opposed to a whole second if we were using the expert system. So I think, yeah. So if it's blue in this one, it could go to this one, in which case we don't care. It could go to that one, in which case we do care. So this one filters again on both. And this time there's an option. So yeah, I think this is going to run fast. I think this is going to be faster than that one. Yeah. Yeah, if I want to release it, I'm going to release it. Clever. Nice. Let's try this one. Now, see, in this case, if it's blue, we definitely want it to go to that one. Otherwise, can we attach? No, we can't attach the one. So if it's green, it's going to go anywhere. Oh, this is complicated because we want green sort of all over the shop. So this would be better if it could output to, if it had 3 outputs, but it doesn't. So let's get rid of that. So if it's blue, if it's either of these, then it could go to that one. If it's blue or green, it could end up in that one. So what we want to do then is, if it's I'm going to try and be clever here. No. Ooh, this is complicated. I think it's going to be that. Because what we want to try and do... Oh, no, hang on. Try green. Ah, yeah. Ah, right. Yes, we have to do that because we have to have... We have to have blue going in there. So we have to have a chain where we got 2 blues into that one. And then anything that's red, we have to have red and only going into those 2. But if it's green, green will go into either of these and then only go into that one. Or go into this one and then go to either of those. I'm not sure. I'm not sure. I'm not sure at all. So I know it's going to work, I'm just not sure whether it will work quickly enough for the intended result. Ooh. Oh dear. Ah, I've got too many in that one. Got too many. Maybe if we said it's green, it goes to that one. And again, that means there'll be no greens in there. Let's see. So I'm thinking if I'm filtering all the reds into here, it can only go to there. Actually, yeah, although it says red and green, it doesn't have to be reds. It can be anything. Okay. It's a little bit high. It's fast. So I don't want the greens to go anywhere they shouldn't. I don't want to trash them either. I think I'm going to release that one and see if they're alright with it. Maybe I should have just fed the blues straight into that one and that would have been quicker. Still made a profit, so I suppose it still works. I'll just check something. Right, so now we've got something that instead of just colours, this is going to do shapes as well. So this is sift. Okay, so this is this is the equivalent. So if it's a shape rather than just a colour. Okay. I'm curious actually. I ought to be thinking, what's the sort of target age range for this game, because this is quite deep stuff really. So if it's a triangle, we want to go straight into there. Otherwise size. We're not interested. We don't give a shit. Trash it. This is the same as the colours, only this is shapes instead. This is what it said about the speed controllers, because you see, hello, A slows it down. D speeds it up, so I've just sped it up a bit so I can get through this. Go faster! Let's go faster! I'm happy to release that because that's going to do what it needs to do. But I'm going to guess that we're going to look at how to use multiple sifts to get us what we want out. Probably to create a custom node. Oh, it's got DLL nodes, which means that we can compile these and make them faster. Aha! This is getting interesting. This is getting interesting. Calculate egg parameters. Alright, so the eggs come in 3 shapes, so yeah. So this is going back to our colours. So this is saying if we've got sift, which is an expert system, if it's a circle then we want to dump it into that one. If it's not a circle, then it's going to go here. If it's a square, we want it to go there. If it's not a square, then we want to go. We want it to go there. Oh, hello. No, hang on. So, if it's neither, it could go to a random one. So, if it's then a square. Oops, shit. So if it's not a if it's a circle or a square, so yeah, we're going to need to do another couple of filters. So if it's a circle, well, hang on, no. Ah, no, this is an if else. Yes, so yeah. So if it's a circle, it's going to go there. If it's not a circle, that's a square or a triangle. So if it's a square, it goes into that one. Then, if else, it's a triangle. So it's going to go here. Oh, hang on, no. In which case, if it's not a circle and it's not a square, then it has to be a triangle. So it goes there. Right. Oh, logic. Logic, you're wonderful. Psychology. So, defining a person's type based on behaviour. Okay. So this is... Ooh, right. So this is a combination of colour and shape. So sift does the shape. And this does the colour. Ooh. Right, well we should be able to do this. So this has got 2 shapes, and this has got 2 shapes, but this has also got 1 shape that we only want. So if it's a triangle, if it's not a triangle, we're just not interested at all in there. So sifting out all the triangles first will be quicker, I think. So let's grab everything that's a triangle and then put a colour tree on it. So if it's a green triangle, we definitely want it to go there. That'll be fast. If it's not, ooh, we don't want blues. I want a sort of knot in here. See, I'm building this how I might build it, which is probably not a good sign, actually. So we want to filter the greens. So if it's blue, they want to go to the trash. If it's definitely green, then we'll go there. Okay, I'm not sure how many nodes we're allowed here. Oh, 8. Ah! Right, we're only allowed 8 nodes, and we've already used 4. Trash can counts as a node. Okay. Now, I think... Now, because these will accept squares... The rest is just down to colour. So I think anything that isn't a triangle, which would be a circle or a square, only needs to be filtered by colour. So that way, if we just stick blues in there, eh? Oh shit! Rats. So if it's a triangle, it'll only go here. If it's anything that isn't a triangle, it'll go here. Something. We want circles to go that way as well, don't we? But on here, we need a sift to say if it's a square, we can chuck it in there. Otherwise, we bin it. And we need another sift on here, do we? No, we don't, because it could be... No, because if it's red, it's either going there or it's binning them. So let's have a... No, we can't use a sift. No, we just hadn't run any circles. No. Could have it go there. because there shouldn't be any triangles. Ooh, low accuracy. Okay, let's try on colour. So, if it's green, go there. And then let's do a triangle. So, if it's green, and it's a triangle, then we want to go there. That's pretty straightforward. That means if it's a blue circle, this is actually starting to stress me out a bit. No, what we want. Because there's exclusiveness here. If it's green, it can only go there. If it's blue, it can only go there. So this way, if we say it's red, then it goes here. If it's a red triangle, we're not interested. So if we put another colour on here, so we want something that's going to give us a blue. So if it's a blue triangle, I want to bin it. So if it comes through here, we're not interested in triangles at all. So if it was a blue triangle, a red triangle, or a green triangle, we want to get rid of it. Or a red triangle, in fact. Otherwise, let's chuck it in there. Red square, it's going to go in there and then go out there. If it's a blue circle, it's going to go up there and then into there. If it's a green triangle, it's going to go down there, straight into there. If it's red, it could go into there. And if it's a triangle, get binned. It's a red square, or could go into there and then go into there. It's a red circle, it could go into there and go into there, that's fine. Okay, let's try. If it's triangle, Oh, we can zoom out. So I'm thinking... Aha. So, reds could end up on either side. Now it can't be a triangle. So let's ditch triangles. Again, if it's not... So if it's... Yeah. Don't ask me how I'm working this out. I'm gonna run out of time. Fuck. Oh no. I'm gonna get there. Just, ooh, it's gonna be a bit slow. Oh! Bollocks. See, I think my order is correct. Oh, right. No. The components I've used are correct, and what I'm doing, I think, is correct, but it's obviously the order in which I put these in isn't. I think it must be on the shapes. It must be on the shapes. if it's a blue non-triangle, then we'll filter it into there. No. If it's red, no, we've already filtered on triangle, haven't we? So penciling that evenly splits the red squares. So if it's a red circle, then it goes there. Otherwise, it's going to end up so if it's green circle, oh no, we can't do that. This is doing my boxing. See, even with this, if it's a blue triangle, it could end up here and then get randomly split between these two. So you'd need to stick a colour differentiator here. So that by that point, if it's a blue square, it probably goes there. Otherwise, this is going to do my head in. This is absolutely going to do my head in, but in a good way. So I think I'm going to need some more time on this one, and I'm running out of my time to just do a quick hour scattergun look at this game. I'm liking this. This is really cool, and it's going to drive me nuts because this is the same kind of challenge that I get in work, where I've got to take data like this and shuffle it around. Now, it's a little bit easier in work because I can do case statements, which is if it's this, or this. And these are sort of if else, and then a sort of random. Now you don't get, because of this random element here, in that if it gets to here and it's not, if it's green, for instance, then it just goes either of those, and then I've got to filter again. But I can combine statements in a different way in code, so this is a little bit unfair on me, I suppose. But this is cool. This is an interesting way of introducing people to real life situations. I'll be interested to see if it's got like a case statement type node later on. So in the meantime, I'm going to call it a day here. I would recommend looking at this if you are. I mean, this would probably work even with quite young gamers because this is visual, and that's the point of. I think I forgot what the language is on the Raspberry Pi on Raspbian, but it breaks it down into quite easy components. I suppose the reason why they're doing not multiple ifs or actually saying that, yeah, I could do it in a different way. But there's also this idea that red squares could end up in both. Now, in programming terms, it's not really the same thing. You want to, if you've got a red square, you want it to end up in one place. This is kind of evenly distributing it, which is very unusual in the kind of stuff I do with databases. So I think this is not necessarily the right kind of thing. But yeah, this is This is curious, and I like it. I really like this, so I would recommend this in a lot of ways. So I'm going to call it there. You will probably see this at some point on the Game Grin streams, but by all means, check out this game. This is While True, Learn. So, main menu. DLL is now an option. Okay. Exit. I'm hoping it's saved there. So, While True, Learn. Look out for this game, and if you get a chance to try this, try it. This is really quite neat, and I think it's worth exploring, worth spending some time with, because if you aren't a programmer, and you are interested in the kind of stuff that goes on behind AI, because this is where we're going with this, expert systems, deep learning, it's all AI. If you're interested in how those actually work, this is probably a good way of getting into it. I mean, I'm surprised this hasn't seen a lot bit more in the press, because I think this is quite a nice way of introducing people to the subject, because you're making simple this is introducing simple logic, which is at the heart of things like AI, is the ability to make decisions, and yes/no decisions. When you start expanding those into sort of yes/no maybe, it gets really quite interesting and quite deep. This is real life type stuff. So definitely check this out if you get a chance. If you want feedback, then feedback through GameGrin. Go to the GameGrin.com site, join us on Discord, and knock me up through there. Otherwise, go to twitch.tv/AJ Crowley, and you can get hold of me through there, or ajcrowley.games, which is my website, or ajcrowley.live. Try and get hold of me, basically, because this is the shit, I think. This is cool. Have a good one, take care, enjoy yourselves, and I will catch you on another stream. Later.